I'm trying to use a push button with a launch pad to turn an LED on and off. When I push it, the LED sometimes doesn't work. Heck, sometimes the LED randomly turns on. So what's going on here? Is it because the pin is broken? Is it because this is a launch pad and not an Arduino? No, they both do the same thing. In this episode of AddOhms, we're going to take a look at how to use pull-up resistors. We will start by just looking at the microcontroller board by itself. Now with nothing connected, we'll use this multimeter to measure the value of this pin, which is set to input. And we see 0 volts, or right about 0 volts. Okay, now let's write a quick program to print the value over serial. What the heck? Why is it changing randomly from low to high? We call this pin with nothing connected a floating pin. Instead of a multimeter, let's see the signal of the pin using an oscilloscope instead. Oh wow, check that out. There is a big signal here. Even if you can't read an oscilloscope screen yet, you can guess that this does not look right. Adding a frequency measurement, we can see that the signal is 60 Hz. Here in my lab, I'm surrounded by EMI radiating at 60 Hz. This energy finds its way into the I/O pins on the Launchpad, or Arduino, or Raspberry Pi, or BeagleBone, or, okay, you get the point. The energy finds its way into the I/O pins and causes the pin to see noise. Guess what? The same thing is a problem when we connect a button to our microcontroller. Let me draw a schematic of this simple circuit. Notice what the schematic shows when the button isn't pushed. We left the pin floating. All of this EMI noise bombards the pin, pushing it around, which turns into a random high and low. Adding a 10K resistor from the pin to 5 volts fixes this problem. We call this type of resistor a pull-up resistor. It pulls up the pin to 5 volts when nothing else happens. When we push the button down, there is now a path from the other side of the resistor to ground. Going back to our scope and multimeter, we can see the button responds by being 5 volts when not pressed and 0 volts when pressed. Note, this inverted logic tends to trip people up. When you push the button, the microcontroller sees 0 volts, which is typically a low. And when the button is not pushed, your microcontroller sees 5 volts or a high. Just keep that in mind when you're writing your code. Microcontrollers like the Launchpad or Arduino already have built-in pull-up resistors. They are simple to use. All you have to do is change the code from input to input pull-up, and the button will be stable. Have questions about pull-up resistors? Leave them with this video. For show notes, visit addohms.com/ep15. If you'd like to help support AddOhms, in addition to sharing this video with others, visit addohms.com/support, where you can either buy a DVD or take part in our new Patreon. Thank you for watching another AddOhms tutorial.